So example 5, look at example 5B on page 445. What operation is in the middle? Division, so we automatically multiply the reciprocal. So a plus 1 over a plus 3, a plus 2, times, when we flip, a squared minus 9 over a squared plus a minus 12. So looking at the top, the first fraction, a plus 2, is that already factored? Yes. So we don't do anything. Basically, this whole first fraction, we're just going to rewrite. It's already factored. But the other fraction, neither one are. So looking at the top right-hand side, is there a common term there? No. Is that difference of squares? Yes. Some of you recognize that that is difference of squares, and you should. You should be able to see that by now. What are the factors of that then? So what do you write? A minus 3 and a plus 3. If you don't know that, you can use quad 3 for that difference of squares. So if you go back in, do another quadratic and push enter there. So what is A for this problem, for the top there? What's in front of your A squared? A 1. What's your B? 0. There is no B. So you make B 0. What's C? Negative 9. And it tells you your factors are x minus 3 and x plus 3. So you can still use quad 3 even for difference of squares. That one is way longer. You should be able to see that and automatically know what your factors are. So we hit enter to do the bottom there. A is 1, B is 1, and C is negative 12. What are your factors? What? No, those are your zeros. No. Factors. Yeah, x minus 3 and x plus 4. What's the factor? So what can we cross? This should be a's. Your calculator is always going to give you x's. Put in whatever variable it is. What can we cross off? A plus 3s we can cross off. What else? A minus 3. And he just walked right into the track. So what's left on the top? A plus 2. And on the bottom you have a plus 4. And he wanted to cancel out a 2. That's not uncommon. Probably half of you would have done the same thing. So this right here is the perfect example of the difference between the two. If you had 2a over 4a, what's 2 over 4? 1/2. You would absolutely have to simplify that. That's not an option. 2 divided by 4 is 1/2. Here, 2 divided by 4, so you want to put 1/2. You cannot divide that. Absolutely cannot. And how do you know you cannot? It's being added. You see this plus sign right here in front of the 2 and in front of the 4. That is one factor together, a plus 2. You either cancel all of it or you cancel none of it. Have to get that through your head. So these are the monomials. There's no plus or minus anywhere in there. Here, there is. Both of them are being added. So you can't cross. So here, you would. You get a over 2a. Here, you would not do anything other than leave that. So maybe it would be helpful anytime you have those to keep them in parentheses. Maybe that would at least help you see that that is one term together. You can't cross off the 2 and the 4 there. That's the biggest confusion of this whole section for most people, is wanting to cross those off. Got one more example to cover at the top of 446. It's a complex fraction. It's one fraction written on top of the other. This is another problem you don't need to write down like it is in the book. That looks like a big, crazy, confusing fraction. We got 4 levels of fraction there. All you're going to do is multiply the reciprocal of the bottom one. So the top fraction, r squared, over r squared minus 25s squared. And you're going to change it to times, and you're going to flip that bottom fraction, the bottom of the complex. So the way it is now, what's on top of the bottom fraction? R. So you just flip that. So it's 5s minus r over r. So there's no need to confuse yourself with those complex fractions. You treat it just like all the other problems that we've done. Multiply the reciprocal. Now, this is a combination of monomials. Is there any plus or minus here? Or here? No. So those are original rules for the first set. Here you do have pluses and minuses. So, r squared, is that already factored? Is there anything you can do to that? Is there a common term, or if it's only one term, though? Anytime you just have one term, you're going to leave that. R squared minus 25s squared. So, is there a common term there that you can take out of r squared and 25s squared? No. You do pretty much have to recognize that's difference of squares. No, not really any other way around that. R squared's a perfect square, 25's a perfect square, s squared's a perfect square, and there's a minus in between. You just have to recognize it. So what's the square root of r squared? R minus the square root of 25 and the square root of s squared. So you have r minus 5s and r plus 5s. If you had put in your calculator that a was 1, b was 0, and c was negative 25, it would tell you x minus 5 and x plus 5, but that's still not going to give you the answer really to that problem. Times 5s minus r over r. So what can we cross off? You can cross off an r. So where would you have an r left? In the top. So we'll change that to r. And 5, what can we cross these off? Right, what's the problem? So what do we got to do? Right, so here's how I would do this. I would cross this off, I'd put a negative out front of it, and I would change the order to r minus 5x. We just changed that part to make it negative and flip it into the right order. Now what can we cross off? The r minus 5s's, because now they are in the correct order. So what's left on top of the fraction? What? Negative r. You got an r left here and a negative left there. So negative r, and what's left on the bottom? R plus 5s. So again, what do some of us want to try to do there? Cancel those r's. Looks like you got r over r. Can't do it. You got to remember. How do you know again? There's a plus right next to this r. R plus. You cannot cross those off when it's being added. Keep that in mind. Let's do example 6a, and then I'll give you some homework. So let's look there. So we got x plus 3 quantity squared. divided by x squared minus 16. And we're going to write times. We're not going to write that complex fraction. So what's going to be on top of the other one? X plus 4 over x plus 3. So looking at the top of the left one, what does that squared sign mean? What does a squared ever mean? So it's good that you kind of got that ingrained already. So basically that just means you got it there twice. You got 2x plus 3's. You will have problems like this in your homework where you'll have that exact scenario. You got to know just write it twice. That's what that's wanting you to do. So what's the bottom? Difference of squares. So you would write the square root of x and 4. What's the square root of 4? Or 16. So plus 4 and x minus 4 there. Anything change in the second fraction? No. X plus 4 and x minus 3. So what can we cross off? X plus 3. That should be a plus, sorry. So we can cross off one of those and that one. What else? The x plus 4's. What else? That's it. So what's left on the top? X plus 3 over x minus 4. You shouldn't even want to cross. I mean, some of you might try to cross off those x's. Can't do it. One other thing to show that might happen, you might end up with 2x times x plus 3 over 4 times x plus 4. So can you cross these off at all? No. But out front, you have 2x over 4. That's not, there's no addition in here, is there? Or here? So you can. What is 2 divided by 4? If you cross that off, you'd have 1x, and if you cross that off, you'd have a 2. So that, you would be required to do that. So then you'd have x times x plus 3 over 2 times x plus 4. So again, if anything that's being multiplied out front, that's, you can cross that stuff off. It's just, you can't cross these x's off when they're being added or subtracted from something else. Any questions before homework? We will do 2 through 32 even. And 38 through 52 even. And that is on page 446 and 447.